uh, that how to solve that closed loop transfer function, right? So when we talk about, I mean, yeah. So some of the thing that I have solved in the previous lecture. So today I'll be solving some more advanced closed loop kind of system. So when we talk about, let's say this one was our particular system. Uh, And again, I'm telling you, this is very important. If you understand these things, then most of the problem in process dynamics and control will become easy. So this one is U, and let's say this one is G2, right? And here there will be a comparator, right? And after that, from this point, there is a feedback, right? Whenever you see this output is coming back to the input to the getting compared at the comparator, then it is feedback. If here it is negative, then it is negative feedback, right? So we'll have to see the sign of feedback. If it is negative, then negative feedback, and if it is positive, then it is positive feedback. So let's say GC is there, G1 is there, right? And here I'm assuming a measuring instrument having a transfer function H, right? Now, and this is called as closed loop and negative feedback. This is called as the closed loop negative feedback, right? So here your output will be, let's say, C, right? And your input is R. So R is called as your input, C is called as your output. And here, yesterday I told you that there will be an error E that is equals to R minus that C will be coming, and here it will be going in this form H into C, R minus H into C. That is called as the error, right? And U, here you see here at this particular comparator, what is happening? U is there, and that U is called as the load of the system. C is output and all, right? So yesterday I told you how to solve this particular system. So since here error will be entering into GC, right? And after that here it will be coming. So I'll tell you, let's say here I will be naming this one is A, I'll be naming this one is B, fine? And uh, fine. And here I'll be naming this one is D. So what is the value of A over here? A will be equals to what? This error into GC, and you know the value of error is R minus HC into GC. Now what will happen? What will be the value of B? The value of B is equals to A into G1. You have calculated the value of A, that is R minus HC, right, into GC into G1. Is it clear? So let's say this one is going to comparator with the positive and positive, right? So what will be the value of D? The value of D will be equals to B plus U, and you know the value of B. So you will substitute here R minus HC into GC G1 plus U. And what is the value of C? C is equals to D into G2. So your C is equals to D into G2. And you have calculated value of D. So C is equals to D. So R minus HC into GC G1 plus U. And this will be multiplied with your G2. Right? Now, since this one is your output and this one is your input, so your transfer function should be C upon R. That will be the transfer function of this closed loop. Is it fine? Where C is your output, already I have written. So we are very much interested in knowing the value of C by R. So how can I calculate? So you will have to solve this particular system of equations over here, this elementary mathematics kind of thing. So I can write C is equals to R minus HC, fine, into G1, G2, that is GC. This should be GC, right? This is GC. GC, G2, G1, fine, plus U into G2. Again, C is here, right? So I'll place C in this side. So if I'll take common C, so it will be 1 plus H GC G1 G2 at GC G1 G2. I hope this picture is clear, right? That is equals to UG2 plus R GC G1 G2. Fine. So in the next slide, I can write C is equals to UG2, that is UG2 divided by 1 plus H 1 plus H GC G1 G2 plus next one is R term. So R GC G1 G2. Oh, sorry. That is R GC G1 G2 divided by 1 plus H GC G1 G2. Fine. And this one is the case. So this one is your output. This one is your output. And this one is your load. And this R you see here, this one is your input transfer function. So now if I want to know, see, one thing is that what is happening, what happens in this process, sometimes either your set point, this one is called as the input or set point as well, set point, and this one is called as the load. What happens, sometimes your load will be 0 and sometimes your set point is 0. Is it clear? So let's say if your set point is 0, sorry, if your load is 0, right? First case, if load u is equals to 0, right? So what will happen? This will be 0. So your value of C is equals to R GC G1 G2 divided by 1 plus H GC G1 G2. Fine. So can I write C upon R? That is your output. That is your input. That is equals to GC G1 G2 divided by 1 plus H GC G1 G2. So now this is your output, this is your input. R is your set point, right? So here load is 0, set point is changing. And if this kind of problem is there, this problem is called as the servo problem. Servo problem. In servo problem, what we generally do, in servo problem, generally we assume our load U is 0 and we will be changing our set point, that is your R. R will be changing, and with that we will be getting the output by input, that is set point change. Will be observing the dynamics of the output with respect to change in the set point, right? This was the first case. Now if I talk about second case, if your R is 0, that means your set point is equals to 0, means load u that is not equals to 0, and this kind of problem is called as the regulatory problem. Regulatory problem. And when we talk about the regulatory problem, already I have discussed that your set point will be 0. So these particular things will be 0. So your C is equals to UG2 upon 1 plus H GC G1 G2. So your C divided by U, that is equals to G2 divided by 1 plus H GC G1 G2. So we have got two transfer function, that is this one is also a transfer function, that is equals to G2 upon 1 plus H GC G1 G2. And this one is also a transfer function, that is equals to transfer function for the, this one is transfer function for set point change. This one is transfer function for load change, means regulatory problem. So these two problem is very, very important kind of problem that arises in process and control, right? So generally, what you see over here, when we talk about that transfer function for set point change, you see in the top, this is GC G1 G2 upon 1 plus GC G1 G2 into H2. So, so here you see for set point change, GC G1 G2 divided by 1 plus GC G1 G2. All these things is happening. But when we talk about C upon U, so only G2 upon 1 plus GC G1 G2. That's all. So the thing is that how the transfer function is, just wait one second. Oh, yeah. So I was talking about that transfer function for the set point change, right? So in set point change, when R will be changing, U will be 0, then you have to multiply all these forward loop, that is GC G1 G2 divided by 1 plus open loop transfer function GC G1 G2 H, right? That is what you see here. And in case of regulatory problem, this is only on the top is G2. That is after that U, this is G2 divided by the whole one, right? Is it clear? So, so directly you can write for servo problem, first servo problem, that means set point change, right? So this one is your output, that is C. This one is your input R, load is 0. Is it clear? So your transfer function will be equals to GC G1 G2 divided by 1 plus GC G1 G2 into H. Is it clear? So your transfer function C upon R, that is equals to your transfer function, that is equals to GC G1 G2 divided by 1 plus GC G1 G2 H. Means this one is forward loop transfer function, and 1 plus open loop transfer function. If why I am calling it is a open loop? So if I will break this open loop from here, so what will happen? It will be open and it will be like GC G1 G2 and H. It will be in the same line, right? That's why it is called as the open loop sometimes. So that's what the case is. But I hope these things is clear. I crack these things with the help of your basics formula and basics loop solving. And when I talk about a regulatory problem, means your load is changing or set point is equals to 0. Here you can say load equals to 0. So the transfer function will look like this. That is G2 upon 1 plus GC G1 G2 into H. Here your load will be there and here your C will be there. So C divided by U, that is equals to G2 upon 1 plus GC G1 G2 into H. Right? This is your transfer function. Any doubt? Anyone has any doubt? Tell me. So if there is no doubt, then I hope these things is clear. So if I tell you to solve this kind of problem, this one is GC, this one will be G1, fine. This one is U1. Here in this problem, I am giving two load, right? And again, sorry. So let's say this one is your G2. Again, second comparator is there. Here I am giving two load, that is also positive and that is also positive. Fine. Here there is G3. It will be going like that. The output is feedback. There are two measuring instruments, that is H1, that is H2. Here is a comparator where this particular things will come and will get realized. So here this one is R, that is positive, that is negative. This is a feedback loop, right? So, and here this one is your output C. So if I tell you calculate the value of C by R, U1 by, sorry, since two load chains are there, so that C by U1, and next one is C by U2. What will be the value? Tell me. Now, I hope this things is very clear to all of you. This one is your H1, this one is your H2. So again, I won't be solving the whole problem, just I will be writing the thing. But at least you should try at least once. Please try. There are two load, right? This one is a load first. This one is your load second. R, this is called as the set point. Here it will come and it will then generate an error, right? Again, this error will move forward. This will see the load. Again, it will go to G2. Again, it will see second load. Again, it will come out and it will give an output C. And again, C is output. It will be taking back to the input with the negative feedback, and it will be generating the error, and it will be running in a loop kind of thing, right? So how can I solve? Here you see what is C by R. C by R is C by R is multiplication of all these forward loop divided by 1 plus multiplication of all these loop, right? That's what the case is. Yeah, GC G1 G2 upon 1 plus H GC G1 G2. So the value of C by R you can write here C by R, that is equals to multiplication of all these upper loop, that is equals to GC G1 G2 G3 divided by 1 plus multiplication of all these loop, like that. Fine. So this is 1 plus GC G1 G2 G3 H1 H2. This is your C by R. Is it clear? Now they are asking C by U1. So what is C by U1? So when we talk about when we will be changing U, so what happens? Let's say here, if I'll be changing U, then the transfer function will be equals to that the transfer function between C and U, that is G2 divided by sum 1 plus sum of all the transfer function, multiplication of all these transfer function. Right? So can I write here C by U1 is equals to what is after U1 but in between C and U1, that is G2 G3. So it will be G2 G3 divided by, I told you, 1 plus all these transfer function, that is 1 plus GC G1 G2 G3 H1 H2. Right? Now they are asking C by U2. So C by U2, what is between U2 and C? That is only G3. So I will be placing G3 in the numerator and upon 1 plus all these transfer function, 1 plus GC G1 G2 G3 H1 and H2, right? So this will be your transfer function, and this is the way that we can solve these kind of complicated transfer function, right? So I hope the thing is very clear to all of you. How can we solve? Anyone has any doubt? Okay, so if you don't have any doubt, then I'll solve some next problem, that is overall transfer function. that is your overall transfer function for multi-loop control system. When there will be a multi-loop, in the earlier right now we have seen there was only single loop, but if there is a multi-loop, let's say how we can understand the multi-loop. This one is comparator, your input, that is your set point. This will be your set point, right? So here you will see there is transfer function of GC1. Again there will be a comparator, alright. Here there is a transfer function called GC2. Again there is transfer function called G1. Again it will come to the comparator. This is positive. And here there is a load of U1 similarly, right? Again there is a Z2. This is a bit complicated, but don't get scared. I'll solve this. And this one is U2, right? This is positive. This is positive. This one is G3. This one is C. Is it clear? And from here, you'll see there is a feedback here. Fine. This one is negative. This one is positive. Fine. There is a feedback. And again, from here, you will see there is a feedback. Let's say this one is your H1 and it will be feedback to this particular thing, right? This one is your positive and this one is your negative. Negative feedback is there both of the place in both of the place. And let's say here there is also a measuring instrument having transfer function is S2. So now here you see this one is first loop and this one is the second loop. So there are two loops, right? Don't get scared. I'll solve these things very easily. You will understand these things very easily. I'll break this loop, right? So now first what's the I mean what is the best way to solve this particular problem? First try to see the smaller loop, right? Right? So this one is your smaller loop. If you will see, I'm just making a yellow envelope. I hope this thing is visible to all of you. This loop that is inside this yellow envelope, right? This is very small loop that is called as the second loop, right? So I'll solve first that second loop. Oh, I lost my cursor. Yeah. So first I'll solve a small loop. So first step is solving a small loop. So I'll be making the small loop over here. This one, and let's say this one GC2. Your small loop is G1. You don't have to make these things, but I mean this is just a simple procedure. If you will practice, then it will be very handy for you, right? So this one is your H2, and this one is simple, right? So this will be going in this way. Fine. So let's say this one I want to understand. I will be replacing this small loop with a particular transfer function. So what I told you, if I want to replace this one is your input, let's say input is I, and this one is output. So I can replace this whole loop with output by input kind of thing, and that will give the transfer function of this whole loop. So I am very much interested in knowing the transfer function of this small loop. If I get the transfer function of a small loop, directly I'll replace this in this form. That is transfer function here. And I'll place this in place of this small loop, right? So that transfer function over here is what? That is output by input. How can I calculate output by input? So this one will be your output. This will be coming. So this will here, that is negative feedback. So here H2 multiplied with your output O, and here there will be error. The error will be I minus O into H, and again here it will come, that will get multiplied with GC, so E into GC2, right? And again it will come E into GC2 into G1. Is it clear? So finally you will see E into GC2 into G1, that is equals to output, and our E is I minus OH. I minus OH, is it clear? Into GC2 into G1, that is equals to O. Is it clear? So here I can write I minus OH2 into Gc2 into G1, that is equals to O. And we are very much interested in knowing the value of O by I. So I'll make O in the different second side, right hand side, and I'll keep I in left hand side, right? So I Gc2 into G1, that is equals to O. I'll take common, and 1 plus H2 Gc2 G1. So the value of O divided by I. So that is equals to Gc2 G1 divided by 1 plus H2 Gc2 G1. So this is our transfer function. So the transfer function here I will be placing in the loop now in place of that bigger loop, a smaller loop, right? 1 plus H2 Gc2 G1, right? So I will be placing this block over here in this particular place, right? So now you see, if I want to calculate, if there is a loop here, there is transfer function, this one, and if I want to calculate output by input, that is transfer function of this loop, the transfer function will be only multiplication of this GC2 into G1 divided by 1 plus GC2 into G1 into X2. That's it. First, in the numerator, multiplication of this thing, that is forward loop, divided by 1 plus the whole transfer function, multiplication of the whole transfer function. That's it. So now I can make this particular closed loop transfer function in this way. This transfer function will be there. So this closed loop will look like in this way. So this one is your R, which is your input, fine. This one is positive, right? And here there was GC1, is it clear? And after that there was a comparator, and here there was a small loop. So I'll be replacing this small loop as the transfer function of a small loop, right? That we have calculated over here, this one. So I'll be placing there, and after that, there was a comparator. Here, there was U1. Is it clear? And after that, there was G2. And again, there was a comparator and second load was there. Fine. Here, there was a G3 and that was C. Fine. And after that, there was a feedback loop. Here, it was H1. And the output over here is coming back to the input at feedback minus. Right? So this one is negative. So the transfer function of this one we have already calculated. That is, what is that? GC to G1. So the transfer function of this one is your GC to G1 upon 1 plus H2 GC to G1. Right? So now we are very much interested in knowing the value of C divided by R, because this is our main loop. This is your output. This is your input. So what is C divided by R? So I told you again, if there is a feedback loop, so the value of output divided by input will be equals to multiplication of all these loops, first, second, third, fourth, which is in the forward direction, right? In this particular line. So I will multiply GC1 and this transfer function as well. So that is GC2 G1 divided by 1 plus H2 GC2 G1. Fine. Multiplication of G2 again into G3 and divided by 1 plus again all these things multiplied with this one. Fine. So 1 plus GC1 and GC2 G1 divided by 1 plus H2 GC2 G1 into G2, G3, H1. So this one is your transfer function of the whole closed loop that we have here. We had earlier in here, right? So the transfer function of this particular closed loop we have calculated here. That is this one. And the value of GC1, G1, G2, all these things will be given in the problem. But the thing is that how you can calculate this particular thing, that's very important. Is it clear? Tell me. So if I say this one is your GA and let's say GB is equals to, I'll multiply this one G2 and G3. So how this will look like? So GC1, GA, GB divided by 1 plus GC1 GA H1. So it will look like very small. So I'm just assuming I won't writing these things repeatedly in the problem. Just I'll assume this one is GA and this one is GB and I'll substitute here. So it will look like this one, right? So I hope these things is very clear to all of you. Anyone has any doubt? Tell me. That's not any doubt. Are you here?
Sir, it's clear.
Okay, good. So if it is clear, then I'll move forward and we'll solve